All right, back again. This time we're going to solve some logarithms. I hope I've got a marker here that's working. I think it's the one that's working well. So here are the logarithmic equations that I'm going to work on. Pause it and read about them if you want, but I'm going to do one at a time. But I think I got to prep you first to show you what's going on. All right, so let's start with 5 to the 1 times 5 to the 2 equals 5 to the 3, which could have been written as 1 plus 2. I'm going to look at the number 1. The number 1 is the exponent you put on top of a 5 to get a 5. The number 2 is the exponent, and I'm adding this exponent. 2 is the exponent you put on top of a 5 to get a 25. That's what a 2 is. And if I add that up, I get 3. 1 plus 2 is 3. And 3 is the exponent you put on top of a 5 to get a 125. I hope you can see a pattern there. 5 times 25 means that I could have written this as the log base 5 of 5 times 25 is the same thing as the log base 5 of 125. That seems clear enough. Well, knowing that we can do that an addition of logarithms, provided we have the same base, then those rules of exponents come into play, and it looks like addition means I can multiply the two quantities. Okay, so now I'm changing this to some unknowns, and let's see if we can figure out how to find them. Log base 2 of x and log base 2 of x minus 2 equals 3. Okay, it's a rapid fire, so I'm just going to do it quickly. You're trying on your own. Well, I know that I can multiply those. I hope I do it correctly. I have to multiply x times x. And I have to multiply x times minus 2 because there's two things over here. And that equals 3. We've been talking about how to solve logarithmic equations. You change the way it's written. The same way we can solve addition of 1 becomes subtraction of 1. You just rearrange things with the inverse operations. The inverse operation of doing logging is exponentiating. So if I wanted to look at log base 5 of 25 equals 2. I could rewrite that so the numbers appear differently. I could say that 25, let's say it's an unknown. I don't know it. Well, I know it came from putting a 2 on top of a 5. So right now, I think that's an exponent, which goes on top of a base. So I'm going to move it to this side. I know it's awkward moving it there, but that's the operation that I just put on the other side. And that's still equal to x squared minus 2x. We now have an entirely different type of problem, a quadratic equation. And the first rule of solving quadratic equations, usually, contrived problems. You try to set it to 0 and factor. So x squared minus 2x minus 8 equals 0. And you try to factor. And there are two numbers that multiply by 8, 2, 8, and are 2 apart, 2 and 4. And it looks like I want it to be negative, so the bigger number gets the negative. So there are two critical numbers here, -2 and also +4, which produce zeros. I'm going to put a -2 in here. I can't. That log base 2 is saying produce quantities. You can't do 2 to the something and get a negative quantity. You go ahead and try. You try things like 2 to the -4. And I hope if you looked at the previous video, that's still 1 over 16. That's still a positive number. It's not a negative number. The only number that works here is 4. What do you put on top of a 2 to get a 4? I hope you said 2. What do you put on top of a 2? If I put a 4 in there, 4 minus 2 is 2. What do you put on top of a 2 to get a 2? I hope you said 1. And I hope you add 2 and 1 and you go whoopee. All right, so now I'm gonna do the next three quickly. You're gonna try them and try to follow. That's the first stage of learning. And then hopefully I give you a worksheet. And we do a couple every day. We do one every day till the end of the term. Then you get to put that in your pocket and actually say, I think I understand what I'm looking at. All right, so the next one, log base 2 of x minus log base 2 of 5. I don't know that number. It's a little bigger than 2. Equals 3. Ah, subtraction. I bet you're already saying if addition is multiplication, subtraction is division, and you would be right. We have a logarithmic equation. How do we write it? We rewrite it by changing the order. That quantity is produced by putting the exponent 3 on top of the 2. Well, that looks like x over 5 is equal to 8. I guess my answer is 40. Yep. Yep, 40 minus 5 means 40 divided by log base 2 of 40 minus log base 2 of 5 means that I'm doing log base 2 of 40 divided by 5. Oh, 40 divided by 5 is 8. What do you put on top of the 2 to get an 8? I hope you look over here and you go, whoopee. Tell it's getting late on a Friday, can't you? Guy's losing his marbles here. All right, next one. Next one is 3. Log base 4 of 2x plus log base 4 of x. These numbers mean nothing to me at the moment, but we're going to work with them, right? Addition, I guess I'm going to multiply. That's a single log now. Single logs are easier to work with. 2x squared equals 2. Oh, that's an exponent. Where does it go? On top of bases, but I like to put it here because I'm highlighting that we have just done that operation on the other side. So that's 2x squared. Looks like 2x squared equals, can I use the eraser here and say 16? Can I use the eraser again because I'm getting tired and just write 8? X squared equals 8, so x equals plus or minus the square root of 8. I got to make sure that when I put these numbers in the parentheses, they stay positive. Oh no, that's going to be negative root 8. I'm only going to look at the square root of 8. What's 2 root 8? I don't know. Times root 8. Now let's see, 2 root 8 times root 8. You know, I think the square root of 8 times the square root of 8 is 8. So 2 times 8 is 16. All right, so I'm going to put 16 in here. What's the exponent I put on top of? Oh, I hope you look over here and say, whoopee. All right, next problem. God, I hope I got record on here. Yeah, at this stage of the game, I oftentimes forget what I'm doing completely. Log base 2 of x minus 6 plus log base 2 of x equals 4. So I think I've had 2 requests, one for the evaluation of the logs and one for solving log equations. And then I had a request for some trig, which we'll do next. All right. Oh, I got addition again. I think I can write that as a single log. X squared minus 6x equals 4. Oh, I guess x squared minus 6x equals 2 to the 4. I go to the eraser again. 2 to the 4 is 16. So I guess I'm going to come back here just for spatial purposes. So that looks like x squared minus 6x minus 16 equals 0. And all that looks factorable because I know 2 times 8 is 16, and that those numbers are 6 apart. So x minus 8, because that wins out, x plus 2 equals 0. I've got 2 answers here, positive 8, negative 2. I'm going to be very skeptical of negative 2. I'm not going to use negative 2. I know I can't have a negative inside that quantity. I guess it's 8. So let's check 8 out and see if it works. So I'm having fun saying whoopee. 8 minus 6 is 2. Oh, that's a 1. 8. That's a 3. Let's see, 1 plus 3, we look over there. And I get to say whoopee one more time. All right, I'm going to end the video. Hope it helps.